on using chip models to add and subtract integers. Before I get started, in class we talked about, in your book, the black circle represents positive numbers, the red circle represents negative numbers, and to get 0, you would have to add a positive to a negative. So if we add a positive plus a negative, we're always going to get a 0. That's the beginning of the thinking for a chip model. Some of the chip models are easier than others. But we're going to start here with just some samples. This chart looks similar to your homework chart. And I'm going to take a look at what we'll call example number 1 right here. And let me just move that out of the way for a bit. And this will be number 1. And it's telling us we're going to start with 3 positives. And you'll need a rule in here. And the rule I'm going to put in is that we're going to add 4 negatives. So we learned in class that if you have a black and a red, when you add them together, they cancel out. So this chip model, each of these combinations, like this, for example, makes a 0. And that makes another 0. And so since each red dot cancels out a black dot, we end up with 1 negative left. So our value that we're going to have left is just 1 negative. And then our number sentence would just be that we started with 3 positives and we added 4 negatives, and our final answer is -1. So that would be an elementary level problem. But these get a little trickier if we change the situation. So in this problem, number 2, we're going to start with 5 positives and 1 negative. But we're trying to subtract 3 negatives. And that's where the problem came in class. So in other words, we have 5 positives to start with, and we have 1 negative, and we're trying to subtract 3 more negatives. And we have to figure out what to end up with. So not only do we want you to get the answer, but we want you to be able to demonstrate this with a chip model. So what we talked about in class was creating a 0. If I bring in a positive and I bring in a negative, since this value here is essentially 0, I haven't changed what I started with at all. And so the idea is that I want to be able to take away 3 negatives, but I only have 2. So I have to keep bringing in zeros until I have enough negatives to take away. So I've just brought in another 0, and now I can subtract out those 3 negative dots, or the 3 reds, because I'm going to be able to now take away 3 red dots. And so since those are gone, I now have 1, 2, 3, 4, 5, 6, 7 positives. So that's what I end up with. So we're not using a number line model, but we are solving the same type of problem. So we should come up with the answer of 7. If we did use the number line model, I'll bring in a second page here. have to. It's not letting me do that. If I did want to use that number line model, I could do it in phases. So we know that without a number line model, we know that this is 4, but we still are having some work practicing how to do 4 minus -3 with the number line model. And so I'm going to go ahead and show you that. So if this is 0, that's probably a little hard to see, and I did a number line model for this, I should get the same answer. So I would start at 0 and go to 4. That would be 1, 1, 2, 3, 4. So let me shorten that up. And let me finish labeling my number line. Now, I'm going to start where I left off, and instead of subtracting 3, which if I were subtracting 3, I would go to the left, I'm subtracting the opposite of 3, so I'm going to go to the right. And that number line model also shows me that my answer is 7. And I felt like you guys were doing great with the number line model, but need just a little practice with the chip model, because we didn't spend as much time on it. So going back to just the single page, we'll do this last example. So on this example here, it's a little bit different because now we know what we started with and we know what we want to end with, but we don't have a rule in this box. So we have to figure that out. But if I start with the 4 positives and the 3 negatives, and I have to figure out what to do here to end up with 2 negatives. From the picture, I can think of these 2 and these 2 canceling each other out because they make zeros. So really, I just have to get rid of this 1 negative.
That's fine. I'm just setting my stuff.
So I'm going to write subtract. And I'm going to subtract 1 negative, because when I do that, that would make this cancel with this. So my rule is going to be subtract 1 negative. So I have to put minus a negative. And that, in the end, will give me the final answer of 2. And that's what you're going to practice tonight.